So today we're going to be talking about vectors as mathematical objects. So just like with numbers, you can add, subtract, multiply vectors together, and we're going to take a look at why we might want to do that as well. So just a quick reminder from yesterday when we talked about vectors, we're making sure we remember that vectors are a object that has both a magnitude and a direction. So we look at our direction, measured the exact same way. We measure those in polar coordinates, and then our magnitude, which again is similar to those polar coordinates, just the distance we've gone from our starting point. Usually we just draw these at the origin to make them a little bit easier. Yesterday we looked at converting these from a magnitude and direction into component form, where we look at the component form as the x and y components. So that would be your x component and your y component. And we wrote those in this bracket notation. And again, that should have looked very, very familiar from switching from polar coordinates into rectangular coordinates. To find the x component, we're just going to take the magnitude times the cosine of theta. And to find the y component, we're going to take the magnitude times the sine of theta. We're just using this idea of a right triangle to convert those. Again, when vectors, rather than using radians, we're using degrees. But as long as we put our calculator in degree mode, we should be good. Now, the nice thing about vectors is once we have these in this component form, doing the math with them is actually really, really easy. So we're going to start out just looking at adding vectors together. And so I've got 3 vectors on the top of this page here, and adding them is pretty much exactly what you'd want it to be. So if I'm taking v plus u, I'm just going to go ahead and write this out. Negative 2, 5 is v. And I'm going to add on 4, 7. All I'm going to do is just add the components together. So I'm going to add the x components. Negative 2 and 4 makes 2. 5 and 7 is 12. And so my vector for v plus u is 2, 12. I can do the exact same thing if I'm adding more than 2. Add the first 2, then add the next 2. And so here you might have something like u is 4, 7. V is negative 2, 5. And W is 12, 7. And I can just add all of my x's together. So 4, negative 2 is 2, 12 is 14. 7, 5 is 12. Another 7 gives me 19. So a lot of times you hear that called the resultant vector. Subtracting is pretty much just the exact same thing, except I'm going to subtract instead of add. So if I want to do u minus v, I've got 4, 7 minus negative 2, 5. And just like with anything in math, if I have 4 minus a negative 2, we need to keep in mind that we're really adding there. So that gives us 6. 7 minus 5 is 2. And so we've got our resultant vector 6, 2 with our horizontal and vertical components. Now vectors, there's lots of different ways you can multiply. The only one we're going to talk about today is multiplying by a scalar, which means we're taking a number times our vector. And the reason it's called a scalar is that's going to just scale up or down our vector. It's going to point in the same direction. It's just going to be, for example, twice as long now. So if I'm doing 2 times v, the way we're going to write that out is just 2 times the vector v. And I bet you would have guessed we're just going to multiply each component by 2. So we're